Today we will be providing Dexter here with a number 8 CAD/CAM crown. Prior to prepping, the restorative material should be selected based on aesthetics, occlusal forces, and other factors concerning the patient's original occlusion. For Dexter, we'll be using Emax as our restorative material. Number 8 will be prepped to allow for adequate material thickness. While prepping, it is important to visualize the shape and size of the burrs within the mill. These burrs tend to be larger, so a smooth, clean prep will allow for easier milling of the intaglio surface. A well-defined margin and visibility of that margin will allow for an accurate scan and 3D digital reproduction of the prep. If the margin is subgingival or difficult to visualize, cord packing or a laser can be used to reveal the margin. Now that the tooth is ready, you can isolate in preparation for scanning. You can use something like an Optrogate or an isovac. It is important to have a path in mind for when you are scanning. This will allow you to be efficient and to have a clean scan. Start occlusally and work towards and past the prep tooth. Rotate the tip buccally and move back towards the initial point of scan. Rotate onto the lingual and work towards and past the prep tooth. For this video, we will be using PlanScan's E4D software to design our crown. There are generally 3 scans needed. This is the scan of our prep. Here is our opposing scan, and here is the buccal scan of the prep with the patient occluding. Using the buccal scan, we can align the prep scan with the opposing scan to establish a 3-dimensional relationship between the 2 arches. Since we are dealing with the aesthetic zone, scanning from K9 to K9 will help the eyes when designing number 8. Now we can begin to denote our margin. We can start by defining the orientation of our prepped arch. Next, we will digitally trim our die like a technician would do for a lab-made crown. At this point, I like to use the paint tool to get a preliminary trace of the margin, and then refine it using the Add Segment tool. Rotate the die to verify your margin from different angles. You can see that the incisal edge looks sharp and not rounded like it should be. Keep that in mind, as this will lead to issues further along the line during the design process. At this step, we want to establish our crown's incisal alignment with adjacent teeth, as well as the general size of our crown. Using the information from previous steps, we can use the autogenesis feature to create a proposal that will have contacts with adjacent and opposing teeth. By clicking on the icon with gears in the upper left, you can control the different parameters of autogenesis. If the proposed crown is far from ideal, design the crown with autogenesis off. Once you have a proposal that is a good base for designing your crown, you can begin refining it with tools like the rubber tooth tool. The eyedropper tool is useful for adding and removing material in specific areas, while the smooth surface tool is useful for removing harsh lines. Dexter's number 9 lacks anatomy, so the smooth surface tool can be used to remove the anatomy placed by autogenesis on number 8. When making your adjustments to your design, be sure to rotate the model at different views to ensure that your crown will emulate a natural tooth in accordance to the rest of your patient's dentition. Now that we have our general tooth form, we can go ahead and establish our contacts. Contacts can always be reduced once the crown is milled, but to minimize the amount of adjustments needed, try to get your contacts to a seafoam or dark blue color. The same goes for your occlusion. The eyedropper tool is useful for these adjustments, and the smooth surface tool can be used to smooth out our additions and reductions. To ensure that we provide the patient with a crown that can withstand everyday use, the crown must be made with minimal material thickness in mind. According to Ivoclar, you want your margin to be at about 1 mm, your facial and lingual reduction at about 1.2 mm, and your incisal reduction at about 1.5 mm for interior Emax crowns. The dialog below deals with margin ramping. The percent indicates how much of the tooth margin is in contact with the crown versus cement. Once the final details have been made to the crown, the location of the sprue can be decided. Avoid placing the sprue on the facial and proximal surfaces. Next, compare the proposed crown with the milled simulation. This simulation takes into account the milling limitations of the mill's burrs. You can see that the mill will have difficulty milling the incisal portion of the intaglio surface. The crown will likely require adjustments to the intaglio surface before properly seating. A smooth prep with rounded corners will avoid this issue.
The design will now be sent to the mill. The Emax block should be firmly secured into the mill in the appropriate orientation indicated in the plan scan software. Once the crown is done milling, remove the sprue with a handpiece and inject some object fix into the intaglio surface. Place the crystallization pin into the object fix and glaze the crown with Emax glaze spray until the crown is frosty in appearance. Instead of using the glaze spray, a rubber polisher can be used to give the crown a nice shine after it has been baked. For this video, we will use the P3 program for firing our crown. The P3 program takes about 15 minutes and is the fastest option for firing an Emax CAD/CAM crown. The purple Emax crown is now a nice shade of A2. The crown should be allowed to cool prior to seating. Once cooled, the crown can be seated following the same protocols for a lab Emax crown.